Well, hi, good morning, and thanks so much for joining me in my shop for another day on this radio. I'm hoping what I'm going to be doing today is finishing off the capacitor replacement, but first, to finish up what was going on at the end of the last video. So the last video, just to recap, I discovered that the 6AQ5, which is installed here, when I received the radio, it's not this exact tube, it's a different tube, is not the correct tube for this radio. It's supposed to be an EL95, and although the pin arrangement of the two tubes, the EL95 and the 6AQ5, are identical, popping this tube in should nominally double the plate current in this radio. That's the big concern. The big concern is, put this tube in, too much current flowing. Not for the tube, but for this cathode resistor and for the output transformer. So I did a couple of preliminary things at the end of the last video. I quickly checked the temperature of the transformer as best I could. It was going up. And the temperature of the resistor, not so high, which is kind of weird. So I did measure the voltage drop on here. It was about 12. If the resistor is a 370 ohm resistor, I think that's its true resistance, then that calculates out to about 35 milliamps of current. So this tube, I believe, I'd have to check this, I think it runs with 45 milliamps normally, I'm not sure of that. And the other tube runs with half of that, 24 milliamps. So the radio is built for 24 milliamps through this tube, and there's a chance there's a lot more going through here. If I don't pay closer attention to this, after a long period of operation, the output transformer may overheat, may smoke, smell, all that kind of stuff, even if it doesn't go defective. Or this resistor may open or go high. It's already gone high, and we're going to start right here with what is this resistance right now. The other thing is too, when the radio operates, this resistor gets a little hot, a little warm. It doesn't get hot, it gets a little warm. Its resistance could be varying, and this could be controlling a lot in this radio, happening in a way that's a little hard to realize what's going on. So we're going to measure its cold resistance, which I think I measured before at 370, if I remember right. I probably don't remember right. Let's find out what it is now. .337, so I probably converted the 37 into 370. So it's actually very close to its correct resistance. I mean, it's right on, really. So what happens when it gets hot? So what we're going to run the radio again. We have other things to do with it anyway, a little bit, and give it some time to warm this up. I can't measure the resistance while it's running, but I can cut the power off and then measure the resistance and see if it's different at that point. Somehow I don't think it's going to be any different at all. I think if it were cycling up and down with heat, it would never come down to 337. I think this is probably exactly the same as it's always been. So that raises the question. Doesn't really raise the question, it leaves the question. So how come it burned up? So this particular tube is running at 35 milliamps. The last one had a short in it, which may or may not have affected its operation. The tube itself is very, I don't know. I couldn't test it in my tester because of the short circuit that's in it. So I really don't know how good the original 6AQ5 was. All we know is it had a short. Could the short have done this? I don't know. You could ask yourself too, yeah, did this happen in like 3 minutes, or did this happen in 3 months of operation? Okay, I think my head is ready now for some adventuring. And we should also double check the voltage drop on here. Sure seemed like 12. And 12 was I think 12 is very good, a very good bias voltage for this tube. 6, let's just check that again. 6AQ5 QR 6AQ5. Typical grid. Grid number 2. Grid number 2. Grid number 1. Oh, circuit resistance. Well, that's the type of resistor you need to put on the grid. 6v6. Maybe I have to look at a 6v6. Grid number 1 to plate. Oh, these are capacitances. Yeah, okay. Now look at a 6v6 because that's what this tube really is. Originally a 6v6, just kind of shrunk down, I guess. So, okay, so 6v6, and we want to find grid number 1. Here it is, grid number 1, control grid voltage. Yeah, 180 volts B plus minus 8, 250 B plus 12.5, 315, 13. So 12 is a high bias. I think it's just fine. Zero signal plate current. 45 at 250. 29 at 180. What is the plate voltage in here? Can't remember. I can't remember for sure. So we should take a look at that too, the plate voltage. And we should check the screen. We should check all the voltages on that too. We should check all the voltages on that too. So to do that, I need something here. Here it is. Okay, here's what I need. Tube extender. It gives me a contact point from above for each of the terminals. See if it'll fit in here. All these socket problems, am I just creating more socket problems? Okay, so now I can touch on those. 6AQ5. Better get my book open here and ready. Oh, I made a diagram of this somewhere. 6AQ5, 6A. Let's use the book. 6AQ5. I'm going to set this over here. Okay, I think we're just about ready. Get my book to stay. I want it. Okay. Now, I'm going to fire up. Power. There we go. So the plate voltage, not B plus, but the plate voltage would be pin 5. French. Was that the AM band? Yeah. Wow, hey, that sounds great. Enchanté. So, plate voltage is again, pin 5. Pin 5 is rate 3, 4. This is pin. What's the radio doing? Here we go. Purrs. Yeah, 20 volts, chill. $175. Okay, I've got restricted power here. Let's make sure it's on. My gosh, eh? This is in the wrong condition. There's just no sound. Wow. This is Okay, problems continue. Now, with it playing, so we know for sure. There we are. 268 on the plate. That's quite a bit. 268 on the plate, and the screen is the next pin over, pin 6. 260 on the screen, 269 probably either side of the output transformer. Why did I make a noise? L'enseignant souhaite une réponse plus musclée que celle prévue par le gouvernement actuel. Nous sommes désignés comme des ennemis. Il faut bien prendre acte que nous sommes leurs ennemis. Le projet de loi doit être présenté mercredi. Yannick Dumont-Baron, Radio-Canada. Et voilà, c'était les informations. Excellente journée à notre antenne. Vous écoutez, ici Radio-Canada, première. Jeepers creepers. Even this.
Bonjour et bienvenue à cette première émission de la semaine. C'est Quaid au microphone avec vous et très heureuse d'être là ce matin.
Don't do that.
On va parler de
Oh boy.
nos adolescents, nos enfants qui sont en ligne.
I seem to have had almost zero effect on those sockets so far. So I haven't really tried anything mechanical with them. I haven't tried squeezing the pins back. I think that's what's next on the list here, is to try to squeeze down the pin clips inside all the sockets. Now, going to do the voltage drop here to be sure of it. C'est le cas quand on voit ce documentaire-là. Donc, 3 femmes qui ne se connaissent pas sont accompagnées de 2 réalisateurs à 160 km dans le Grand Nord à pied en What happens when this tube is messed up? Like that. 18 volts. There's more current flowing for that to happen and back down. That's interesting. So during an excursion, the current flow in this tube goes up. Whatever the excursion is. Whatever it is that's happening. It's up to 18. That's a 50% increase. So 35 becomes 45 milliamps. The tube's at its max, and then is it not? You know what? Heater current. I'm getting confused here. Heater current. What is the plate current on this guy? Plate voltage, plate dissipation, plate current, please. 6V6.
Bonjour. Madame Trump, alors juste rappelez-nous en 2 mots qu'est-ce que fait la Fondation Marie-Vincent, parce que vos lumières vont être très éclairantes pour nous ce matin. La Fondation Marie-Vincent, ça l'aide...
I'm going slow here because I'm actually thinking about other stuff while I'm doing this. QRS TV.
Donc, on offre des services thérapeutiques là, aux enfants qui ont été exposés à des images là, sexuellement explicites. Dans ce cas-ci qui nous intéresse ce matin, c'est à titre d'expert dans ce sens.
Plate current.
Alors, je commence avec vous, Catalina Brisseno, parce que bon, cet article dans la presse, publié le 17 novembre, parlait de cette nouvelle plateforme Omega.
It didn't show it here. It could be in milliamps. Milliamps. Oh, they are a maximum signal plate current. Maximum signal plate current. For the... So we're around on the 250. 47 milliamps. 47 milliamps is what this should be putting through. With minus 12 bias, 250 plate, 250 screen. That's exactly what's going on here pretty well. The variation is going to be plate resistance and all these kinds of things that are inherent in the tube. Oh gosh. So, you know, can this radio really run with this tube safely? I think what I'm going to do, I'm going to let... Now, what's happening during that? What's happening during that stuff? Look at that. Oh, more than 20. She's cooking up. This is cooking up, this is cooking up, and the output transformer all cooking at the same time. What exactly is coming off here? Is it can't be the plate connection. Could it? Yeah, well, you couldn't conduct that kind of current through the screen, I don't think. You wouldn't tend to hear it in the speaker, would you? If the plate disconnects, no current in the output transformer. So that leaves grid. So the grid bias disappearing, the tube running wild. The grid bias is here. Don't touch it, Joe. The grid bias is here, and we measured it. It's gone up. It's more negative. Well, I don't get it. But I get this. If the radio is not operating like the way it is now, there's definitely a risk of overheating that, and that. Maybe not so much the tube, but output transformer. So, risky business here, still. I think I want to let the radio run for quite a while, until it reaches its temperature. It's about 9:15 now. I let it run for 15 or 20 minutes, and then make temperature measurements and decide if, even under this condition, there isn't a risk to operating the radio. Anybody speak French? So it's been on now for another 15 or 20 minutes, and am I wrong? Is there a little bit of distortion now in the sound of it? Yeah, I can't leave it up now because leave the volume up because copyright problems. Okay, think, Jim, think. Now, let's do the heat run test thing. Check this resistor here first. I'm going to block the heat from the tube here. Came in once or twice and did this. So that's about 50 degrees, the resistor. There's quite a bit of heat in the area there too. But just the heat, just the heat, just the heat. It kind of spreads everywhere eventually. Now, up on here, so you can see that very obvious red spot there. This is actually a resistor that's up in there, a high wattage resistor. I hadn't noticed before. And this part back here is more the output transformer. So the temperature here, if I just tip this a little bit, a little tiny plus sign sitting right there, 31, 32. I'll put my hand up in there and check it too very carefully. It looks like the transformer's not hot, it's just this resistor. 62, and that's not terribly hot either. 60, you know, that's a reasonable temperature. And why did they stick the resistor up there? I think for exactly the reason we just saw. It gets hot, and better to mount hot things up high, or even away from the chassis if you can do it. You see, they mounted this up high. It doesn't look high, but it is just a little off the board there. A little more air circulation through. So what have we got here? So we got a radio that looks like it will kill itself if the there we go. If the tube goes wonky. Tubes that are all sensitive in their sockets. We still have a socket problem, I'm sure. So I think my next step is to attempt to squeeze the clips or in all the sockets. Okay, let's switch off. Yeah, I mean, if this radio went into somebody's home and the tube contact slipped and they turned it on, left it on long enough, it might burn this resistor. It might. And of course, the only way to find out is to let it operate in that bad state and then see what what condition develops, and that's a bit risky. It's a little bit risky because of the output transformer. Okay, now work on these sockets. This tube's not very hot. Take a closer look inside there and see what we can see. Just before I start poking around for fear of making the situation worse than it is. So I'm looking for inconsistencies in the two prongs that are sticking up the clip. I'm looking at each one of the holes and trying to figure out if light on it here. If one of them looks awkward, let me just get this settled here. If one of them looks, or if they look different, and they do not. So what I see is the inside prong is fairly tight in the thing there. The outside prong appears to be in a position to spring. But they certainly aren't close together. It looks to me like you could slip a tube prong down between them and not make contact. So, question would be, do I just pinch these together? Both sides? Do I push one over to the other? And what have I got that can fit in there anyway? I mean, that's a tiny. Well, we can try a couple different things. I think the main thing is just pinch them together. What I'm thinking is I'll pinch them together, and when I let go, they'll just spring right back to where they are, because you can't pinch them past their strain point. You're trying to strain the metal, so it'll be in a new position afterwards. And that only weakens it too. So next time around, it's just going to be that much easier to loosen it up. And I think that tube wiggling stun type pulse is not very good for these sockets. That may have only exacerbated the situation. So I have to find some tools here, some goodies. Okay, there's a great view of it. Now, let's see if I can get a tool in here. I just want to watch kind of what happens here. It's so small to watch with your ordinary eyeballs. The camera's in a bit of a problematic position. Let me try this other side here. Hey, where is the? There it is. So the one on the inside, the inside clip always seems to be pushed way in. Yeah, from this angle, it looks. So when you look straight down at this one, it looks pretty balanced. Let's try that one. Which one is that? It's this one. Oh, son of a gun! Right there. Looks simple in the camera, but I need that pin again. I need the pin. I need something so small. And where'd my pin go? There it is. Okay, I got it. Now, let's see if we can manipulate anything with this. We're working on this one here. See, the problem is I've got the camera on a funny angle, so nothing makes sense on my screen when I look at it. So you can see when you wiggle one side, you wiggle the other side. So what that tells me is the best thing to do would be to try to pinch these closed. Oh, I haven't got a pair of pliers that are going to fit in there. There's no way. I mean, let's just check. So these are some fairly fine pliers. Yeah, that's not going to do anything in there, is it? You almost need like a tool, like a two-pronged tool you shove down either side of the clip, and in doing that, it will push the clip together. If I had something like that, Okay, I'm going to stop and try to either fashion a tool to do this, or find one. Oh, okay, here's my first try. This would be nail scissors. Can I possibly... So let's pick this one right here. Can't really even see the clip. It's way down there. I don't think these could go in far enough. Now the camera's going to probably get knocked around here while I'm trying this. I can't imagine. No, I mean, it's the right idea. It's just the wrong tool. I'm sure I'm getting on towards the what? Towards a solution here. Okay, so I'm saying to myself, just before I figure out a way to do this and then start doing it, have I really assessed the problem properly? So I'm going to stick this pin, sewing needle, down into one of these and just see if it doesn't tighten up somewhere. So again, I may bump the camera here. Well, it doesn't seem to be particularly tight in there. And look at the amount of junk that's on these pins still. If I could have found a really nice brush, I would have really got in there and done that. Jeepers creepers. Well, what if the problem really is dirt and I'm going to squeeze all these and it won't do anything? Wow, it's just a silly little problem there. But I don't have exactly the right kind of tool. Not yet. Along my hunting trails, I found a couple of brushes here. You know, these are for cleaning razors and stuff like that. I'm thinking if I cut away all these, except for one set, that one set might be able to rotate it in there and do some much better cleaning. So I think that's what I'm going to try to do. I really don't care if I didn't even know I had this thing until now. Looks a little big. Doesn't want to go down in there. Too many bristles getting caught. I got it in there. What am I hoping to do? Stick alcohol in there and sweep out every one of these. I'll do this one socket here and we'll try the radio and see if I get a positive result from this effort before I try bending those pins. Good. Alcohol dripping everywhere here. Put it right in there. get it to go down in. Okay, now start brushing. Start with this one. Really hard to see what is going on. I'm looking straight at it here. Okay, what's up on the TV? Oh. Hang on. Let's try this one. When I remove the camera, this would be a little easier for me to do than what's happening right now. I'll go right in there. Lots and lots of alcohol. Okay, so I think this is a satisfactory approach, at least the best I can come up with right now. So I'm going to do this one socket, and then we'll play the radio again and see if this stopped the problem. If I can get my camera all the way over there. There we are. Okay, pretty sure things have dried up here. Let's put the tube in. Now, I did put the tube in and out once while there was still some alcohol in there. I thought it might just help out a bit. Okay. Come on. It's really hard to push in. Like, it just feels like it's really being gripped, and it's solid in here. Not quite so solid. Well, that doesn't matter. It feels pretty good. Okay, so the idea is we're testing this tube now to see if its wonkiness is gone. Power on. Is everything okay here? Yes. Power on. Now we know that if the sound doesn't come up properly, there's a chance the tube is killing the radio. Wow, so the volume seems low. It doesn't seem to have the volume it had. Wait a minute, I'm on restricted power. That's probably all it was. Come on, radio.
Et donc, le résultat de cette expédition, ben, c'est le documentaire.
Oh, that's a strange one. As long as it sounds right, it's okay. Now, everything's okay. Try this tube now. Hold something there. Huh. Are you kidding me? What's happening here? What is going on? I'm just moving. Everything is so sensitive over here that. My God. Okay, this guy. No, it's that one. This didn't work out. I haven't got enough stability in the radio to find out if it's stable. I should have cleaned that socket first. I don't know what's doing that. I don't know if it's this tube I'm wiggling. Doesn't seem like it, does it? Okay, what little bit I'm getting away with here is kind of suggesting this tube's not too bad. Let's clean the socket. Let's clean all the sockets. I'm going to follow that procedure on all sockets. Yahoo! Okay, should be dried up again. Yeah, when you put these tubes in, they feel like they're being gripped really well. Maybe they are. Maybe it is just dirt and wax and oil, or who knows. This one, not so much. This one, not so much. It's being gripped. Gripped. Okay, what are the chances that this has fixed this guy right up? I don't think it's very high. I think it's kind of low. But I'm trying to do the things which are least risky, least likely to cause the problem to get worse, least likely to damage the radio. Getting in there and bending all those things, considering how difficult it is, let's hope this worked. And then I could have bent all those things and find out it didn't help at all. And then I would have done that, taken the risk of the bending thing for no reason. Okay, let's, what am I doing? I'm going to turn on the radio. Here we go. Now we got to get it working right away here. Oh, isn't that great? Doesn't that sound right? Shit. Get in here every time you run this radio and wiggle the tubes until the thing works. That's enough. Okay, so that cleaning thing didn't work. It has to be a mechanical problem here. Oh, great. Okay, back to trying to figure out how to pinch those guys together. I took a look in our sewing stuff, and look at all these goodies I found, including nicely pointed little handles here. Look at that. That's a beauty. Nicely pointed handles. Nice points with handles. That's what I wanted to say. So the question is, can I get down behind on one side and then get down behind on the other side? I think this is a little bit too big. So look at that guy. Wow. Oh, he's got a hook on the end there. That's not good. This is a pretty odd looking thing too. But that's not going to go down behind. It's way too big. So we'll take this bigger needle here. And just try one. And then we need another needle. This is going to take forever. This is. What I'm thinking is I push one in. Let me go on the inside here. Push one in. And then when I put the second one in, that's when the bending will occur. Oh my gosh, this will take forever to do. They're in there. Did anything bend? We better take a look at this. Let's take a look at this. See what we got here. When you get up close, things always look a little different, don't they? But it looks like it's perfectly successful. I'm pushing both tangs towards each other. Now, I can't see what's going on down below there. How close together can you get them? Tricky holding the camera and doing this at the same time. Just bear with me here. You know, yeah. Can't hold on here. Jeepers creepers. And the camera's own wire pushes the camera around when you're trying to position it like this. Hey, that's pretty good. That's not bad. Now, if I got room to maneuver in here, I can't really see in there to what I'm doing. So there I'm doing the bend them together. Let them go. They go right back. See, there's a good chance that you can't bend these together because they're spring. They're spring material. They are not going to get strained here doing this. I'm going to get strained. That's kind of what I want to do right there. Now, don't lose sight of that one. Just knock dirt in there. I just want to put the needle in here to hold it there. That's the one I did. Now I gotta take a better look straight down here. Well, it definitely looks different. Definitely. Okay, so that's the procedure I'm going to do now to all the tube sockets, pin grips, I guess we can call it, and see if that makes a difference. I think this is going to work. I'm hopeful. I become hopeful. Let hope reign forth, because a lot of time here. It better work. Okay, I've done them all. I'm going to inspect them, see what they look like. If I can see that all the clips are now pinched. That's quite good there. Okay, this one. So there's one there. Look, two, oh, there's a bunch, a couple. You know, they're okay. They're off center is what's happened here. What I discovered when I was doing this was I didn't have to use two needles. I didn't have to do both sides simultaneously. I could really do it one side at a time. Whoops. So I'm a little worried that I'm going to shove a pin in here. It's going to go behind the there. So that's what I'm doing. So I did one side, pull the pin out, and then do the other side. This is still, that's a little better. You can see how the two pins are going to strike one of those things almost dead on. But a little bit of wiggling it will get in there. Okay, that's that socket. How about this one? A little more open here. Well, you know, we're going to put a tube in it and give it a try. That'll really show up if I manage to fix this. Now, you're not looking at these before I bent them. Before I bent them, these were all back open as much as you can be, pretty well. Okay, that's good. I think that's good. I think this is going to do it. Let's see, what should I risk on this? Maybe one loonie. Luckily, I don't have any change with me at all, so I can't gamble. I am not a gambler. Anybody notice that? I can't bear to go and, put money into one of those literally one-armed bandits. Oh yeah, so that's probably hitting some of those dead on now. So what I mean by that is you have the clip, and you have the pin coming down from the tube. Right? So it's like this. So you want this to go in between, and what's happening is coming down and hitting the top of one of these. And I wanted to kind of do that, slide in there. That's what I'm trying to achieve here. Doesn't look like any of them should interfere. I'm just chicken to push down hard. No, it feels like it definitely is being resisted. By the time I get it in, I'll have bent all the... Son of a gun. Really? This tough? There, you know what? I'm just not pushing hard enough. Let's try this one. Yeah, that's a good sign too, isn't it? These are hard to put in now. Wow. Wow. Okay, that's really in there. Okay, I've already put this one back in. This last one. I'm leaving the FM tube alone during all this stuff. Okay, it's in. Okay, this is the biggest, baddest problem with this radio by far. Did I finally clear it? I'm not going to find out with my computer. Okay. Good. Let me just take a peek at this. And so I'm on the uh-oh, where's she going? May come back down. Just keep going up. I'm not exactly hearing anything. 16. Oh, now I'm hearing it. Son of a gun. Jeez. My gosh. You know, I got a tool here. I'm ready to use it. I'm ready. Wham! Holy smokes. So, there's not much volume here now. There, volume just came back. Oh my gosh. How can you be doing this to me? Oh, look at that. This is a disaster. This is a complete disaster. Okay. That's not a good way to end the video, is it? It's a complete disaster. I'm not getting anywhere with this tube problem. Oh my gosh. Okay, maybe this might be the end of the video here today, because I'm not sure what I'm going to try next. I got to go away for a big think on this. Thanks for watching.